Hey guys, in this video we're going to look at solving quadratics using the quadratic formula. In this video we're going to solve quadratics that you cannot factor, which is something I covered in a previous video. I want to take a minute and discuss the calculator I'm going to use in this presentation. The Texas Instruments TI-36X Pro is a very powerful calculator. Not only does it have an enormous amount of functionality beyond your typical scientific calculator or standard scientific calculator, it also produces the answers in what's called math print, which means that the answers can include symbols such as pi or square roots and exponents. This is very powerful stuff, definitely for beginner students, because you can get your most precise answers. The Casio FX series, in this case that I have pictured the 300ES, is another excellent calculator. And if you like to color coordinate, the Casios come in all sorts of colors. Be careful when purchasing these calculators because they are very similar to other versions in form factor that are not quite as powerful. So you definitely want to pay close attention to these purchases. And these calculators are as powerful as, in my opinion, and in many cases more powerful than their graphing calculator brothers. At this point, I would focus or choose a TI-36X Pro or a Casio calculator over any graphing calculator. All the quadratic formula is the rearrangement of a quadratic in standard form. If you recall in a previous video, this is the standard form of a quadratic. And what somebody figured out was that if we rearrange A, B, and C into this form, we could follow a series of steps and find out what x equals. You typically do this when you cannot factor a quadratic. And I'll show you guys in a second why that is. So I took the coefficients and the constant and I color coded them so that you could see how they're placed inside the quadratic formula. The quadratic formula is not created through wizardry. Somebody didn't just make it up. The quadratic formula is derived through a process called completing the square. Completing the square is likely the original method that was used to solve quadratics in the first place. Factoring and the quadratic formula came later to simplify that process. I will cover completing the square in a later video in case you're anxious and you really want to know what it is. But for right now, let's see what the quadratic formula does. Okay, so let's solve for x here. I want to solve for x by factoring first. So I'm going to do that very quickly. First, I'm going to subtract the 5x to both sides so I could set it equal to 0. And now I have x squared minus 5x plus 6 equals 0. Now I'm going to factor it. So I get the factors of 6, 1 and 6, 2 and 3, 3 and 2. I found all my factors because the numbers have repeated. And I'm going to place that in parentheses. So my factors are negative 3 or x minus 3 and x minus 2. Because I want to figure out what multiplies to 6 and adds to negative 5. Negative 3 plus negative 2 add to negative 5. From there, I have to set these both equal to 0. Then solve. So I'm going to add 3 to both sides. And that's x equals 3. Add 2 to both sides. And that's x equals 2. Okay, so that's those solutions. This was done very quickly. What I want to say is just that if you need help factoring, you could go check out a previous video I made on factoring quadratics. Now what I want to do is solve this problem using the quadratic formula. To solve this using the quadratic formula, just like when I factor, I have to set this equal to 0. So once again, I'm going to subtract a 5x to both sides. So this way, 5 minus 5 is 0. This term won't combine with any of these, so I'll have x squared minus 5x plus 6 equals 0. Now what I have to do is I have to identify my A, B, and C terms. Okay, so I wrote the standard form of the quadratic as we saw earlier. So now I can identify my A, B, and C terms. A equals 1, because there's a secret 1 there. B equals -5. And C equals 6, or my constant is 6. Now I'm going to take that and I'm going to plug that into the quadratic formula. Okay, now what I'm going to do is I am going to insert my A, B, and C's into the quadratic formula using parentheses. So I'm going to do this for you guys using these colors. So I'm going to place the A's where they go. So I'm going to put them in parentheses. I have a 1 there and a 1 there. I'm going to put my -5 here. And also notice there's a -b here. So this is actually going to become a +5. If I could actually get that to erase. There it goes. Okay, now I have to put my C in place, which goes right here. If you're saying to yourself, I did this a little bit awkwardly, I did, but the reason why I did that is so you could see how the different A, B, and C colors can go into place. Hopefully that was helpful. Now let's actually solve the problem. So, the first thing I'm going to do is get the number that's under the square root. The number under the square root is called the discriminant. It's not really important for you to know that right now, but I figured I might as well point it out. I'm going to get this number first without the square root, and the reason for that is because if you get a negative in the calculator, you will just get a domain error, and if you get an answer that you don't understand, it's going to be difficult to track what happened. So the easiest way to do this is to break this up in a few steps. Oftentimes, students will punch this all into the calculator at once, and if I'm being honest, that takes more time than to just write out the 2 or 3 steps that you need to write here. Take a look at my calculator screen here, and you will notice that I placed directly into the calculator what was under the square root. The Math Print, or these powerful calculators like the TI-36X Pro, allow me to input what I need to as I see it, which is very, very helpful. I got the answer 1, so that means that I could place a 1 here. Now, the square root of 1 is 1. But if you were not sure, you could always just place it in your calculator. Again, notice how I could place this information right in the calculator exactly as I see it. My last step here is to find my 2x solutions. That's what the plus or minus does. So what I have to do is I have to break this up now into 2 parts. One is the positive, or the plus side, and then the other is the negative. And when I have 5 plus 1, that's 6 over 2, or 3, which is the same answer I got before. 5 minus 1 is 4 over 2, which 4 divided by 2 is 2. So just like before, I got the same answers of when I factored. In this particular case, you would not use the quadratic formula because you could factor it first. The point of this exercise was just to show you that it's always worth checking if you could factor or not. The quadratic formula is actually particularly difficult to use when you can factor. Okay, let's go to the next example. Okay, so here's the next example, and first thing I'm going to do is I'm going to set this equal to 0. I'm going to do that by adding the 1 to both sides. This 1 does not go with any of these other terms. So I'm now in standard form. Quickly, doesn't take long to assess this. I recognize that I cannot factor this. Sometimes it is a little bit trickier to see, but with experience you could usually figure it out pretty quickly. Because a is not equal to 1, I'm not going to try to factor this in this particular case. So I'm going to go right to the quadratic formula. I'm not going to go super crazy color coding this time. A equals 7, B equals -6, and C is 1. And now I'm going to place it in my quadratic formula. The -6 becomes positive because that's a negative b. I keep my plus or minus. I'm going to try my best to draw the square root. And I have b squared minus 4, then 7, then 1. Hopefully that's a little bit helpful to see how you actually fill this in. Now if I can draw a straight line here. Now 2 over 7. Okay, once again, I'm going to plug exactly what's in the discriminant, which is the information on the square root, into the calculator. I want to take a second and point out that is a subtraction sign. One thing I forgot to mention, a common mistake that students make is they often use the negative button there. I hate that both the Casio and the Texas Instruments have a dedicated number for negative and subtraction. It often confuses students. Be careful with that. That's a common mistake. This is the negative symbol. Usually looks like this on the key pad. And this is the subtraction sign, which will just look like that. Changes the entire problem. Alright, so now I got 8 here. Knowing that I didn't get a negative or some answer I couldn't move forward with, I'm going to move forward by rewriting the quadratic formula with the 8 in place. I'm going to multiply the 2 and the 7 together and get 14 here. Now I'm going to place square root of 8 in the calculator. And here is why these two calculators are so powerful. Because instead of getting an irrational number such as 2.828427125 non-terminating, so that means that number goes on infinitely, the calculator presented the answer of square root of 8 in its simplest square root term. Or, if you want to look at it this way, its most precise method, because if it was placed in a decimal, the number would have to be rounded up, which makes it an approximation, not a precise answer. So I'm now going to rewrite this quadratic with 2 square root 2 in place. And that looks like this here. And I keep that 2 square root 2 over 14. Okay, my next step, which is my last step, is just to reduce this answer. And what you could do is just look for a common number that divides into all 3 of these. You cannot touch the number that's inside the square root. So that number is just going to come down. The only number I can think of that divides into 6 and to 2 and to 14 is 2. So 6 divided by 2 is 3. 2 divided by 2 is 1, which you don't have to write that 1. And 14 divided by 2 is 7. That is your final answer. That is the most precise answer. Sometimes you can convert this to a decimal, which at TI-36, you could plug it right into the calculator as you like. And the only time I would do that is if I need to use that answer for something. And the way I would do that is I would type in 3 plus 1 square root 2 over 7, then 3 minus 1 square root 2 over 7. From there, I would get my two answers. Here are the two answers separated and plugged into the calculator so you can get the decimals. For right now, I would not focus too much on what that looks like, and get yourself to here. If you could follow this algorithm or a set of steps to get to that final answer, the quadratic formula will serve you really, really well because quadratics are a pillar of math. Alright guys, I hope you guys found this video helpful.